Again to Let's Talk Chemistry with Pastor Dan. We're going to look at practicing for missions. And I pulled up off of calculator.net a example of a scientific calculator here. So that way we can see how to process through using the calculator. Now on your calculator, you'll find this button right here. This is either EXP. On some calculators, it says times 10 raised to the, or it says EE. If you see any of those, that's a button you press. You don't do times 10 and that or anything else, just that button. And we'll show you what I mean. We have two problem sets to do. Here's the first problem set. Okay. So here we go. 4 problems. Calculate the frequency of emission, wavelength that is 348.9 nanometers. Determine the wavelength in nanometers. If an emission has frequency is 5.9744 times 10 to the 14th hertz. Find the energy of an emission if the wavelength is 552.9 nanometers. And identify the wavelength in nanometers if it requires 2.798 times 10 to the negative 19th joules of energy to excite the electron. So again, these are emissions, so we can find the placement of electrons. That's the first set. And then copy these down as well for a second day. Here we go. Calculate the frequency of emission. If the wavelength is 299.6 nanometers, identify the wavelength in nanometers if the emission frequency is 3.98775 times 10 to the 14th hertz. Third one, find the energy of an emission with a wavelength of 435.7 nanometers. And finally, identify the wavelength in nanometers if it requires 7.334 times 10 to the 19th joules of energy to excite the electron. All right, so we have both of those. Make sure those are copied down. I'm going to work through 2 of the problems in the first set and then let you do the other ones. I'll show the answers so that you know what the expectations are and how correct, at least as far as I think they are. All right, so let's get started here. Let's start with the second problem there on the first practice. Determine the wavelength in nanometers if an emissions frequency is 5.9744 times 10 to the 14th hertz. What's new? Well, if you remember, nu is equal to C over lambda. All right, so let's go through our graphic organizer. Nu is 5.9744 times 10 to the 14th hertz. C, speed of light in a vacuum, 3 times 10 to the 8th meters per second. That is a constant. And lambda, our wavelength, determine the wavelength, it's the unknown value. Now, we're going to solve for lambda, so they're going to bring lambda up, nu down, algebra, and we're going to get lambda is equal to C over nu. All right. Take 3 times 10 to the 8th meters per second. Now, I can try to make this a little easier for you to do, and here's how. Remember we converted before from meters to nanometers, and 1 meter is 1 times 10 to the 9th nanometers. Now, if you know your algebra, 10 to the 8th and 10 to the 9th, they're common multiples, and you're multiplying the common base units and multiplying. So when you have common base units with exponents, you can just add those. Because 8 plus 9, we can make it 3 times 10 to the 17th nanometers, and that'll save us a step. We can just use that value whenever working through it. That's what I told my class is a cheat step. All right, so I'm going to convert this to per second because I'm working with it. Hertz is what we express it in. Per second is what we work it in. So that's going to go on the bottom. 5.9744 times 10 to the 14th. All right, so we come over to the calculator. We type 3. Now again, this button's either EE, EXP, or 10 to the X on your calculator. So make sure you have that. Type it. Whoa, didn't go in there. I didn't get 3, so let's try that again. 3, EE, 17. Good. And then we're going to divide that by 5.9744 EXP and 14. Okay. Now we come over here. My seconds cross out, so I'm in nanometers. And you see in the calculator, on a prior calculator, I got 502.14247455.811. That calculator doesn't go as far. Now, how many sig figs do I have? Well, 3 times 10 to the 17th, that's a constant, so that's significant. 5.9744 times 10 to the 14th, that's 5 sig figs, so I get 502.14 nanometers. All right, let's try the second problem. Clear this out. All right, identify the wavelength in nanometers if it requires 2.798 times 10 to the 19 joules of energy to excite the electron. Now, we use 2 equations. What's new? C over lambda. Very good. Now, the other equation that we have, we said for energy is equal to H, that little hat on top, times nu. That's Planck's constant. All right, so start with E. The value we're given, E is equal to 2.798 times 10 to the 19 joules. Planck's constant, 6.63 times 10 to the 34th joule seconds. And frequency is unknown. So we're going to solve up for frequency first. So if frequency is here, and that's multiplication, E is across the same way, so we're going to divide nu, the H value on the opposite side. So nu is equal to E over H. Put our values in. So we're going to put 2 point, so let's clear this, 2.798 EXP negative, where it is negative, or on this calculator, I got to do 19 negative. There we go. Divide that by, divide it on the bottom. There we go. 6.63. Again, EXP 34. And on this calculator, I make it negative. A lot of calculators, you have to do it first. Okay? And that's expressed as a long number. If I put in the scientific notation, though, joules cross out, I'm going to get 4.220 times 10 to the 14th because the fact that I have 4 sig figs, an infinite number of sig figs here, and that's my answer. But that's not my answer. I didn't ask for frequency. I asked for wavelength. So I'm going to have to use this equation. What's nu? C over lambda. All right, so nu is equal to C over lambda. So we're going to solve for lambda, bring the lambda up, bring the nu down, put our values in. Again, we have 3 times 10 to the 17th, my cheat step, nanometers per second, over the frequency that we put in there, 4.25. Let's check that one out now. So we're going to do 3 EXP 17 divided by 4.220. You don't have to put the 0 on there. The calculator doesn't care. 14. Oh, no, that's right. No, that's not right. Let's try that again. 3 EXP 17 divided by 4.220 EXP 14. There we go. That's better. Answer the calculator. Seconds cross out. 710.9004739. And then for sig figs, I've got infinite and 4. So my answer here would be 710.9 nanometers. All right. Now, here are my 2 answer sets. Okay. So we do the first answer set. Good to show you. So there's my second one, and there's my fourth one. You got 2 more to answer there. And then for the second set of problems, work those through. Here's the answer for those. So we get that for the first one, that nanometers for the second one, that joules for the third one, and nanometers for the last one. All right. Does that make sense? Hopefully it does. Any questions, let me know. Take care. God bless. Bye.